Hi, my name is Ahmad and I am going to talk about the GIS based decision support system in agriculture. This is my topic for this evening. About the author is Dr. Reddy. Dr. Reddy joined ICAR in 1976 as Scientist 1 at All Indian Coordinated Research Project AICRP on Drilling Agriculture, Hyderabad. He became Scientist 2 in 1983. Later, he served CRIDA, Hyderabad, as Senior Scientist from 1986 to 1999. In 1999, he joined NAARM, Hyderabad, as Principal Scientist. Dr. Reddy interest in quantitative techniques using statistical methods and models, computational statistics, informational management, and geographical informational system (GIS) applications in agriculture and web design. Introduction. Increasing food demands due to high rates of population growth and major changes in political and economic and social systems have created an urgent need to develop new and revise many existing agricultural system and practices. Decision Support System (DSS) provide a framework for integrating database management systems, analytical models, and graphics in order to improve decision-making processes. The Decision Support System concept was extended to the spatial context by integrating Geographic Information System (GIS) and DSS, which is Design Support Systems, into special design decision support system SDSS. GIS is the tool and technology that handles various spatial database and is a young area of information technology. This spatial information technology allows to examine and analyze a wider range of agriculture related resources such as soil, weather, hydrology, various socio-economic variables simultaneously and accurately. Simultaneous examination of these variables in a GIS environment leads to a better understanding of how agricultural systems function and interact over space and time. DSS with GIS tool can better organize and analyze special data, address the problems related to spatial and temporal variability of various natural resources on which the performance of agriculture systems depends. Special databases developed in GIS as input to analytical models such as simulation models and statistical models enables to model agriculture from field to national and global scales accurately. Output on area action plans at different scales can be viewed through maps. The Special Information Systems and Decisions Support Systems help to manage various agricultural systems efficiently over space to meet the changing food demands without damaging our natural resource base. Therefore, GIS can be looked as an essential and central tool for developing special decision support system. In this article, some applications of SDSS and in agricultural research are discussed. Now we're gonna talk about the special decision support systems for crop productivity management. Productivity management at regional level. This is the first point. Regional productivity analysis involves evaluating spatial soil and weather variability, identifying optimum crop management practices, and predicting productivity of the region under different climates, climatic and management scenarios. This analysis can help regional planners and policy makers in delineating acreage and distribution of areas with high productivity and developing management recommendations for different crops. LAL 1993 extended the scope of applicability of site-specific crop simulation models such as DSSAT, which is Decision Support System for Agrotechnology Transfer, to regional planning, productivity, and policy analysis by combining their capabilities with ARC InfoGIS. An interface was developed to combine DSSAT models with AR CVIEW. And this combined system simulation models predict informations on yield and other crop related outputs for different homogeneous soil and weather combination. And GIS aggregates information from individual units, displays maps, and also presents results in tabular format for the study region. Sign on 1993 demonstrated the use of GIS to investigate nitrogen fertilizer efficiency in Maharashtra state using sorghum crop simulation model coupled with a GIS. The spatial databases of the GIS contain information on soil, weather, and other inputs needed by the SORAM model. The system allows regional analysis, and the output can be in terms of maps. Hence, these combined tools can be used for characterizing the region, locating high-yielding and problematic areas, and estimating their productivity under different management strategies. Productivity management at farm level. Ho Jin Boom 1993 used DSS-80 models at research farm level by developing a software interface with ARCVIEW. The first objective of their study was to expand the use of crop simulation models through a linkage with GIS and the spatial soil database. The second objective was to apply this system to study the distribution of yield, water use, and other agronomic variables as a function of soil spatial variability on a farm level. The results of the study by Ho Jin Boom for the crops grown under rain-fed condition showed a strong spatial variation. It may be possible to capture the variability in crop yields adequately by overlaying many soil characteristics using GIS and appropriate analytical models. This helps in making decisions on varying input use at field level for sustainable crop productivity management. Spatial decision support system for precision farming. The extent and rate of change now occurring in the development of informational technologies have opened the way for significant change in crop production, management, and agricultural decision making. Precision farming technology allows farmers to make informed economic decisions about input use while reducing or avoiding long-term environmental degradation. Adoption of this technology requires accurate geographical maps showing physical and chemical properties and the tools to apply the inputs as per the spatial variability. Conclusion: agriculture production is facing many challenges such as increased cost of production, shortage of irrigation water, adverse impacts of agriculture on the environment. To survive in the highly competitive world made of agriculture commodities, in view of globalization, agricultural producers must produce highly quality products as or at low prices while using environmentally sound practices. GIS has a significant role to play in the decision making process in agriculture at various levels such as field, regional, national, and global levels. GIS is one of the important tools of informational technology IT, highly relevant to agriculture. This technology allows examining and handling a wider range of spatial databases such as soils, hydrology, weather, etc., and integrating with socio-economic variables. Simultaneous examination of these variables leads to a better understanding of various agricultural related process and their interactions over space and time. This leads to characterization of resources accurately and to identify appropriate domains to target new technologies from time to time. Linkage of simulation models such as crop simulation models, hydrologic models, and statistical models to GIS databases is one of the current active areas of research. GIS is emerging as a powerful spatial decision support system. Future study: new informational technologies will be required to make the more detailed and timely decisions necessary for precision agriculture, and introduction of new sensing technologies will enable the collecting of an unprecedented number of soil, crop, pest, and weather observation. Maps created using GIS software can be used during field operation to make more precise and timely application of inputs. Multidisciplinary research will be needed to match measurement methods and analytical techniques with crop production questions of interest to effectively understand and use information about the true variability of measurable parameters within farm field. This is my reference, and thank you so much.